Start.
So, for our group project for computer science, we made a traffic simulation. And this is by me, Austin.
Hathaway.
Harry. And Dylan, who isn't here. So, the classes for this project, we have the vehicle class, which I did, the traffic light class from Hathaway, the road network class from Harry, and the simulation engine class from Dylan, which wasn't ended. And then simulation class, engine class from Dylan. And finally, we got the main module to put them all together and use them. And then we also have Sahan's data collection, which uses the program and collects data, representing it in graphs. So for the first class of the project is the vehicle class, which was done by me. And for this class, we've got for the initialize, we've got first off, the state that the car is in, which it needs to know whether the car is waiting, arrived, or moving, because that will all lead to different things happening with the car on the GUI. And then we've also got the things such as destination, path, intersection, and the vehicle ID, which I didn't end up using. But following that, we've got all of these functions, which first off is the set path. This function it starts with the path as nothing, and in the simulation engine class, it will simulate the road network, and from there it will get how many nodes there are and generate a path based on the start and the destination. And along with that, we've got the update class, which essentially is all about updating the state that the car is in, whether it be going from waiting to moving or moving to arrived, which will mean the car will stop or start or disappear because it's arrived at its destination. And then we've also got the start class, which essentially says if the car isn't arrived, start, which the simulation engine class uses to start the vehicle. And then we've got stop, which does the same thing but stops it instead of starting it. And then we also have the move to next, which essentially says if there is something more in the list of destination, or in the list of nodes in its path, just go to the next node. And then finally we've got the has arrived, which essentially just, if it's arrived at its destination, it will set the state to arrived. And then we also have the representative function at the bottom, which I just used for testing. And then finally we got the representative function, which I just used for testing to see if the vehicle was actually existing. Yeah.
This is my part, which is the part 3, and it combines the first 2 parts from Hathaway and Austin. So I don't think that I need to introduce these parts again. So I wanna explain this code directly. First, there is a graph dictionary, and the key means intersection, and value means list of connect intersections. This is the list representation of the graph. When it starts, I can add a new intersection node into the neural network, and if the intersection already exists, it do nothing. Next, I can create a empty list to store connected intersection. Next, when it has been connected, you can create a road connection from one intersection to another. And also I can check the start intersection if it exists. Also, I can check the destination. Next, there is a term called getNeighbor for this part. And also, from this code, it can return all intersections that can be reached from the current intersection, and it can check if intersection has already exist. Next, about this connection part, it can check whether there is a direct road connection between two intersections and check if start intersection exists. So this is a conclusion. The road network class does not control vehicles or traffic lights. It only defines how roads are connected. Other modes rely on this structure to simulate traffic movement correctly. Maybe someone would ask, why do you need a road network? Because vehicles need to know which roads are connected after leaving an intersection. And the road network provides this map structure. You see a graph.
Okay, so this is my part, it's the intersection part. And this is the model roles and responsibilities. First is manage the states of traffic lights, is control the red, yellow, and green lights at the intersection to ensure that vehicles follow the roads for passage. And second, control the vehicle queue. Maintain the vehicle waiting queues from the east, southwest, and north directions and track the numbers of vehicles in real time. And third, core simulation component. As a hub connecting vehicles, road networks, and data analysis models, it jointly simulates the real urban traffic flow. And this is the main functions. First is add vehicles, include direction at vehicle to waiting queue in the specific directions like south, east, west, and north, and initialize the vehicle's queuing states. And second, switch light. It is responsible for automatically switching the traffic light states, cycling in the order of green to yellow to red, and precisely controlling the passage rates of vehicles at the intersection. And third one is process vehicles. When the target direction is a green light, release a specific number of vehicles from the queue to simulate the actual vehicle flow at the intersection. And the fourth is get queue length. Return the current length of the vehicle queue in the specific direction, providing a basis for real-time monitoring of traffic congestion and subsequent data analysis. And this is the code. Yeah. And at the end of code, I added test code. This is so we can run the intersection class alone and make sure every part works correctly. The test code creates an intersection as vehicles to the N and E queues, checks the queue length, switch the traffic lights 3 times, lets 2 cars pass from the N queue, and checks the N queue length again. When you run the code, you see all these steps in the output, so we can confirm the code works as expected.
So next is the simulation engine, which was originally Dylan's part, however I did with the help of ChatGPT. And the simulation engine is what makes the GUI and also all the timing such as frame rate and all the actions per second, that sort of thing, along with drawing the things in the GUI. And the functions within it are the initializing function, which has the road network and intersections, so it needs to know where those are. And then we also have it generates the positions of the node, it gets those positions of the nodes, draws the roads, and then draws the intersections. And then we also have spawn vehicle. We have spawn vehicle, which essentially just spawns a vehicle with the class from my class section.
So why you call the class name instead of saying my class? What do you
Yeah,
mean
the
by-
vehicle class section, which is just a random number between, well, we've got 16 nodes. We've got, right now we've got 16 nodes, so it'll just get a random number between 1 and 16 for the start and destination, and spawn a car at the start and set a path that eventually will get to the destination. And then the loop function, it loops all of the ticks and that sort of thing. So finally, we've got the main module, which imports all of the simulation engine, traffic light, and road network, which the simulation engine imports the vehicle class, so that's why the main doesn't need to directly do it. And then it gets the road network, and with the code from the road network class, it'll spawn nodes for as many nodes as in a range. So we have 1 to 17, so that's 16 range, and then we have the add intersection, because the add intersection function from the road network class, and then we've got a connection function which will connect the intersections from A to B. So if you have intersection 5 and intersection 12, it'll connect 12 to 5, and then it'll also connect 5 to 12. That way there's two-way traffic. And then it will get the intersections it'll get the intersections and it'll get all of the intersections, and that is for the cars to know where they're going and where they're starting, and it will start the simulation with the intersections and such.
This is my part of the project. Is the data analysis class, which is responsible for analyzing traffic data and showing result using paragraphs. In this program, I create a simple traffic analysis system using Python. First, I define an intersection class to represent each road intersection. Each intersection has an ID and a traffic light state for queues for vehicle counts from north, east, south, east, west directions. When vehicles are added, are sorted inside these queues, which allows me to track cars each direction. I also create method calculate number of vehicle and intersection by adding length of 4 queues. After that, I create multiple intersection using road names and manually added vehicles to simulate realistic traffic conditions. This acts as my data source instead using random values. Then I create data analysis class, which is responsible for analyzing data inside this class. It method to collect names, intersections, and data and their total vehicle counts, which is used visualization. I also implemented a method to detect overload intersections by checking if the number of the vehicles exceeded a certain threshold. I use Matplotlib library to create 3 types of graphs. The line graph shows how traffic varies across intersections. The bar chart compares congression level between different intersection, and pie chart shows percentage of distribution of traffic. For pie chart, I used a format like this to display percentage clearly with decimal places overall decimal places. This I create 4 queues for each direction for my team member credit, and it cars waiting for the each intersection stop, and added vehicle add to cars queues to simulate arriving traffic lights, and count cars each queues here to measure how much traffic is there. Store intersections. Here it store all intersections to analyze them together and detect get the data from graph. Total it collects names and vehicle counts needed to create graphs. Yeah, that's it.
Thank you.
Okay, go on to the demonstration. Stop the video. Okay, leave it, let it go on there.
So, demonstration. This is cut off because we don't. This bottom line is essentially just to have a destination for cars going through these 4 intersections in the middle. So that's why this is cut off. There's nothing there, and that's why the corners aren't connected, because we're just simulating the intersections in the middle themselves. And I can go slow this down, so for testing to see actually how many cars in queue, you can slow down the traffic light, and that will, if I make this say 150, then we can slow down the traffic light, and if once it turns red, it will allow the cars to have a longer time to get there and stop. So right now there aren't many cars, but this will better show congestion. You can also turn up the spawn rate of the cars, and this is our simulation. Yeah.
Okay. Somebody presented about data
Yeah.
analysis.
Yep, the song.
Yeah, I want to see that. No, I'm not talking from the slides.
Yeah.
I want to see it work.
It worked. I never.
No, I mean, I expect it to be an integrated system.
Oh.
Working.
Okay,
Okay, stop the video.
That's keyboard. So this